Okay, Algebra 1, this is worksheet 822, and we're going to do the odd problems on here where we're going to solve the system using substitution. And in all of these examples, we are not going to have a letter already solved for. So we're going to have to make the choice which one to solve for ourselves. And then again, what we're going to need to remember is how to make a good choice. And there's two things we want to look at. The first thing we want to look for is for a variable that has a coefficient of 1. If an equation does have that, we're going to solve for that variable. The second, if that's not available, then the second priority is to determine a coefficient that will divide evenly into all the other terms. Algebra 1, we're going to work on worksheet 822, and we're going to use substitution, and we're going to do the odd problems. And in each of these examples, we're going to have a system where the letter X or the letter Y, neither one has been solved for or is by itself. So we are going to have to choose which variable to solve for. And remember, there's two things we want to look for that will help us avoid fractions. So first thing we want to look for is a variable in either equation that has a coefficient of 1. If it does have a coefficient of 1, we want to solve for that variable because then we will not have any fractions when we have the letter by itself. If that's not available for us, the second thing we want to look for is, will a coefficient of any of the variables divide evenly into the other terms in the equation? If so, we want to solve for that variable because when we divide at the end to get the letter by itself, then we will end up with no fraction. If those two options don't give us anything that will help us, then we simply choose a letter to solve for that's going to produce fractions, but we'll have to work with those fractions, and we'll show you how to do that when we come across that example. Okay, so taking a look at number 1 there, as we look, we see neither equation has a variable that's been solved for. So then I want to look for a variable that has a coefficient that divides evenly into all the other terms. So if I start with equation 1 here, if I look at the letter X, it has a coefficient of 8. 4 is not divisible by 8. Therefore, if I was to solve for this X, I would end up with a fraction at the end, so I don't want to do that. If I look at this letter Y, the coefficient of 4 divides evenly into this 8, and the coefficient of 4 also divides evenly into this 12. Therefore, if I solve for this letter Y, I'm going to end up with an equation where Y is by itself on one side and is equal to something, and on the other side I'm going to have all integers, no fractions. So I'm going to choose to solve for this variable Y right here. So this Y is what I want to get by itself. So in order to do that, I'm going to subtract 8x from both sides of the expression. And when I do that, that's going to leave me 4y. Let me try to get this pen working a little bit better here. So that's going to leave me 4y equals, and then I have the negative 12 minus 8x. Now to solve for the letter y, I'm going to divide by the coefficient of 4, and I have to do that to each term in the equation. So that reduces to y. Negative 12 divided by 4 is negative 3, and negative 8 over 4 is a negative 2x. So what I have is what we had on that previous worksheet, where I have a letter and I have an equal sign, which means this letter and this expression over here are of equal value and therefore interchangeable. So in the other equation in the system, I can rewrite that equation, and instead of the letter y, I can put in this expression here, and that's going to get rid of the letter y for me, give me an equation with just the letter x, and I'm going to be able to determine the value of x. So going to the second equation then, I'm going to rewrite it, and when I come to the letter y, I'm going to insert this negative 3 minus 2x because that has an equal value and is interchangeable with the letter y, is equal to 4. And you'll see this is just like the other worksheet that we did. So we're going to need to distribute the, to get rid of the parentheses first. So this is going to be a positive 12 and then a positive 8x is equal to 4. I then am going to look to add like terms. I've got a negative 6x and 8x on the same side here, so I'm going to add those together, and that's going to leave me with the 12. I then am going to get the x by itself by subtracting 12 from both sides. I want to move this up here a little bit. So this is 2x. 12 minus 12 is 0, and then 4 minus 12 is negative 8. And now that the variable is by itself, I'm going to go ahead and divide by that coefficient to get the x completely by itself. So I have an x value of negative 4, and you'll see that is the correct answer. Now, just like in the previous worksheet, this is equal sign means that the letter x and the number or the integer negative 4 are interchangeable. So I can go back to either of my original equations. I can also go back to this equation here, and wherever I see the letter x, substitute in the negative 4 and determine the value of y. Because this equation is already solved for y, and that's what I'm going to be looking for, all I need to do is substitute it into this x. I'm going to use this equation. So I'm going to rewrite this equation, and when I come to the x, I'm going to substitute in something of equal value, which I now know is negative 4, and I'm going to use that to figure out what my y is. So this is negative 3. Negative 2 times negative 4 is a positive 8. So adding those together, I get a y value of 5. So you can see I have my ordered pair, which is the solution to the system. So if the letter is not solved for, or the variable is not by itself, we get to choose which letter to solve for. We just need to remember how we can make that choice easy for ourselves, and just continue to do that. Number 3 on the worksheet, again, we have two equations in the system. We do not have a letter that is by itself yet, so we're going to have to do that for ourselves. So let's try to make a good choice here. If I decide to solve for this letter x, I'm going to have to divide by 4. 6 divided by 4 does not come out even, so I don't want to solve for that letter if I don't have to. The second letter is this y, and that has a coefficient of negative 6. Negative 6, 4 is not evenly divisible by 6, therefore that would be a fraction. I don't want to solve for that if I don't have to. Going to the second equation, I have this 4x, so that means I'm going to have to divide by 4. 8 is divisible by 4, so that's going to give me a nice even integer. And 20 is also divisible by 4, so I'm going to solve for this x because it's going to give me an equation that does not have any fractions in it. So the first thing I'm going to do is add 8y to both sides. So that's going to give me 4x. 8y minus 8y is 0. So this is 20, then plus 8y. That's a 20, not a 26. Okay? Then we're going to divide by 4. But I have to do that to everything. And we'll do that. So the 4 is reduced, leaving me x. 20 divided by 4 is a nice even 5, and 8 divided by 4 is 2. So because I chose to divide by this 4, or to solve for this letter, I now have an expression that tells me that the letter x and this expression over here are the same, well, it means they're interchangeable. So going to the other equation in my system, I can rewrite that, and where I come across the letter x, I can substitute in this expression because it has equal value. So, starting with this first equation then, 4, there's my x, so I'm going to put this in place of the x because these are interchangeable. Minus 6y is equal to 22. I then just use my equation solving steps. I'm going to distribute first. Hang on, that's not a very good color. You probably can't see that very well. So let's go with this color. Okay, 5 times 4, so that's 20. 2 times 4, that gives me 8y minus 6y is 22. I then look for like terms to simplify. So these are like terms, so I can add those together. 8 minus 6 is positive 2y. Now that everything's been simplified, I want to get the y that I'm solving for by itself. So I'm going to subtract 20 from both sides. Again, I'm going to come up here. So it's going to give me 2y is equal to 2. And then I'm going to divide by 2. So the 2's reduced, leaving me y is equal to 1. So I have the first part of my ordered pair. So now that I have the value of y determined, I know that I can substitute in the number 1 because y and 1 are interchangeable. They're of equal value. I can go back to any of the two original equations or this one that I already solved for x and substitute this in order to determine the value of x. Because I want to determine the value of x, I'm going to use the equation that's already solved for x and simply substitute in my y value. So x is equal to 5 plus 2 times my y value, which is a 1. So that's going to give me 5 plus 2, so y is equal to 7. I don't know why I said y. These are x's. Let's see. Okay, so this should be an x value and x. So my x is equal to a 7. So I have my ordered pair of 7, 1 as my solution to my system. Looking at number 5, again, we have a system that does not have a letter that's already by itself, so we're going to have to choose to solve for a letter. So again, we look for a coefficient of 1. We don't have one, so now we want to decide which letter to solve for. If I solve for this letter, I'm going to have to divide by 5. 2 is not divisible by 5, so that's going to be a fraction. Try to avoid that if we can. If I solve for this y, I'm going to have to divide by 2. 5 divided by 2 does not come out even, so that's no good for me. If I solve for this x, I'm going to divide by 3. 7 is not divisible by 3. And if I'm going to solve for this y, I'm going to divide by 7. 3 is not divisible by 7. So this is a case where we are not going to be able to work without fractions. We're just going to have to work with fractions, and that's just the, there's no way around it. So I'm going to choose a letter to solve for, and again, it doesn't matter. I'm going to choose to solve for this 2 here. And the only reason this y. And the reason I'm solving for the y is because 16 is divisible by 2, so that's going to be even, so I'm just going to have one fraction that I need to deal with here. So the first thing I'm going to do is get this y to be positive, so I'm going to add 2y so it goes to the other side. So that's going to give me 5x is equal to this 16 then plus 2y. Now that the y is positive, I'm going to go ahead and subtract this 16 so I can get that by itself. So this is going to be negative 16 and a positive 5x is equal to 2y. I then am going to divide by 2, and this is why I chose this particular variable to solve for. 16 divided by 2 comes out to be an integer. 5 over 2 I cannot do anything with, that's a fraction, so I'm just going to have to leave it. And then y is equal to this. So I have the letter y by itself, and so the y and then this expression here are interchangeable. It's a fraction, but that's okay. So in the other equation that I didn't use, wherever I see the value, the letter y, I can substitute in this expression because it has equal value. They are interchangeable. So starting with this equation right here, we're going to rewrite it, and when we come to the letter y, we're going to substitute in this value here. So negative 3x minus 7, and there's my y, so I'm going to substitute in this new expression that has equal value, and then continue copying, and so there we have substitution. Again, we have the letter x, so we're going to use our steps to solve an equation just like we always do. So we're going to distribute first. So negative 3x, I have a negative 7 times negative 8, which is positive 56. I have negative 7 times 5 halves, so that's going to be a negative 35 halves. We just multiply numerator times numerator and denominator times denominator equals 15. Now we're going to use what we learned earlier this year, that we can get rid of this fraction now that the parentheses are gone by multiplying every term by this denominator. So as long as I do this to every term, I can multiply any equation by any number that I'd like. So I'm going to get negative 6x here. I'm going to get 112 here. The reason I chose 2 is because when I come to this fraction, this denominator 2 and this 2 that I'm multiplying by are going to reduce to 1. So that's just going to leave me this 35x without a denominator is equal to 30. So after distributing, I can get rid of the fractions. I then am going to look to simplify my equation. I have like terms on this side, so I'm going to add those together because they're on the same side. So that's going to be negative 41x plus 112 is equal to 30. I then am going to isolate the variable I'm solving for by adding the opposite of everything else on this side. So that's going to give me 41x. This is now 0. And this is going to be negative 82. And then dividing by the 41, the coefficient here, and dividing by 41, this reduces to a 1, leaving me x. And negative 82 divided by 41 is a negative 2. Now why is that negative? Oh, I see what I did. This should be a negative 41. So I'm dividing by a negative 41. This should be a negative 41, which means a negative divided by a negative gives me a positive 2. So I have the answer 2 for my x value. Now I need to figure out the y value. So I can go back again to either of the two original equations and substitute in the 2 for x because I now know that those are interchangeable. Or I can just go right back to here because this is already solved for y, substitute it into this expression, and get my y that way. So let's go ahead and do that. So working with this equation, I have negative 8, 5 halves, and then there's my letter x. So I'm going to put in the number 2. Is equal to y, so this is just simply a fraction. So these 2's now reduce, so I have negative 8 plus 5 is equal to y. So negative 3 is my y value. So my ordered pair is 2, negative 3. And again, we use substitution there. We had to work with fractions, but that's okay. We just substitute it in, and after we distribute, we remove that fraction by multiplying by the denominator of any fraction that we may have. Okay, these next few examples we're going to move a little bit more quickly. I'm not going to quite go through as detailed an explanation as we have been. If you're not sure about that, you can look at some of the previous ones for a more detailed explanation, but we're going to move through these a little bit more quickly. So as I look at this next system, I notice again we don't have a variable that's solved for. We look for a coefficient of 1. We do not have one. We look for a coefficient that divides evenly into all the other terms. 3 doesn't divide evenly, 5 does not divide evenly, 7 does not divide evenly, 6 does not divide evenly. So I'm going to have to work with fractions. There's no way around it. So I'm going to have to choose to solve for a variable here. None of these numbers are divisible by any of the coefficients, so I'm just going to have to work with two fractions here. So I'm just going to go ahead and work with this first equation and solve for this letter x here. So in order to do that, I need to get that term by itself, so I'm going to subtract the 5y from both sides. That's going to be my first step. So I'm going to have 3x, that's going to be 0. I'm going to have 1 minus 5y. And then I'm going to divide by 3. So dividing by 3 gets the letter x by itself, but leaves me with 1/3 here and 5/3 here. So x and this expression here are of the same value and therefore interchangeable. So in my next equation I can substitute this expression in for any x that I see. So beginning with this equation, I'm going to have 7, and there's the letter x, so I'm going to substitute in this 1/3 minus 5/3 y into the equation and then finish copying the rest. So minus 6y is equal to 20. You'll notice that that gets rid of the x and I only have y's here. Using my order or my steps for solving an equation, I'm going to distribute first to remove parentheses. So that's going to be 7/3, and that's going to be 35/3 minus 6y is equal to 20. And now I'm going to get rid of the fractions in my equation by multiplying by that denominator. And again, by multiplying that by that denominator, those denominators are going to reduce, and that's okay as long as I do that to every term in the equation. So the 3's are going to reduce here, leaving me just the 7. The 3's are going to reduce here, which are going to leave me 35y. 6 times the 3 is going to give me the 18, and then the 20 times 3 is my 60. Now the fractions are gone. I'm going to combine these like terms. So I have 7. This is going to be negative, let's see, 45, 50, what? 53. Y is equal to 60. And then I'm going to get the variable by itself. Actually, yeah, let's just go ahead and do it this way. I normally would do it a different way just to keep that positive, but that's okay. We can do it this way. So this is 0. That leaves me negative 53y. Don't forget that negative sign is equal to 53. And then that means I'm going to divide by negative 53 in order to make this a 1. So y is equal to a positive divided by a negative is a negative. So my y value is a negative 1. So now that I know the y value, I'm going to go and solve for x. Because y and negative 1 are interchangeable, I can go back to this equation, or this equation to figure out what my x is. X is already solved for here, so I'm going to substitute it into here. Now, if you didn't want to work with fractions, you could go ahead and put it into one of these and avoid it that way. But I'm just going to go ahead and do it here. So x is equal to 1/3 minus, and then I have 5/3 times y, which is a negative 1. So this is going to be 1/3, and now a negative times a negative gives me a positive 5/3. So the denominators are the same, so that's going to equal 6/3, which reduces to 2. So my x value is 2, so I have my ordered pair, which is the solution to this system. On number 9 here, we look at our system. We have no variable solved for, so we're going to have to choose which letter to solve for. We look for a coefficient of 1. None of these have a coefficient of 1. So I'm looking for a variable whose coefficient divides evenly into every other term. As I look at 2x, 2 divides evenly into this 2, and 2 divides evenly into 14, so I'm going to go ahead and solve for this x right here. Now, if you took a quick glance, you'll notice that you could solve for any of these. These are all evenly divisible, so you're not going to get a fraction in this particular problem no matter what you do. But we're going to go ahead and solve for this, so we'll begin by moving the 2y to the other side, adding its opposite. So 2x then is equal to 14 minus 2y. I then am going to divide by 2, again doing that to every term. So that's x. That's going to be 7, and then that reduces to 1, so minus y. So we now know that x and this expression here are interchangeable. So in the other equation, we can substitute this into the expression for any x value that we see. So rewriting that second equation, there's 3 and then there's the letter x. So we're going to put in this expression because it's interchangeable, and so we can substitute. Then we'll copy the rest of the equation. We'll then use our steps to solving an equation. We distribute first to remove any parentheses that we may have. We then look to simplify each side of the equation. We look for like terms. These have some like terms here. We have negative 3y and negative 3y, which is negative 6y. We then isolate the variable, and again, we can do that by adding the opposite. So we're going to subtract 21 from both sides. So that's going to leave me negative 6y is equal to 0. And then we're going to divide by negative 6. So that's going to be y, and then 0 divided by anything is 0. So I have a y value of 0. Now we know that y and 0 are interchangeable. That's what that equal sign tells me. So going back to any of these equations that I've worked with so far, I can put in the value for 0, the value of y, and get my x that way. And again, because this is already solved for x, I normally go back to this one. So this is going to be 7 minus 0, so x is equal to 7. So we have our solution to our system. In our next system, we notice that we do not have a variable that's solved for, so we're going to have to solve for that for ourselves. We look for a coefficient of 1, which we do not have, therefore we're going to have to decide which one to solve for. We want to find one that maybe doesn't give us any fractions, or the least amount of fractions. If I choose this variable, I'm going to divide by 6. 4 is not divisible by 6, and neither is 8, so that's 2 fractions. If I solve for y here, 6 is not divisible by 4, but 8 is. So solving for this 4y would give me just 1 fraction. 5 does not divide into 6 or 12, that's 2 fractions, and 6 does not divide into 5, but does divide into 12, so that would be 1 fraction. So solving for y in this expression or this one is only going to give me 1 fraction to deal with, so that'd probably be the better way to go. Let's go ahead and take this second equation and solve for this 6y, and then we'll work from there. So in order to do that, we're going to have to subtract the 5x, or get the 6y by itself first. So that's going to give me 12y minus 5x. I then am going to have to divide by 6 to get that variable by itself. So that gets me the letter y by itself. This is -2, and then here's my 1 fraction that I'm going to have to deal with. So again, because we have the letter y by itself and we have an equal sign, we know that this expression here and the letter y are interchangeable in the other equation. So I can substitute that in. So writing the other equation, and when we come to the letter y, we're going to substitute in this expression. So -6x plus 4, there's the letter y, so I'm going to put in this expression, -2 minus 5 over 6x, and then equals -8. So we're then going to do our properties, or excuse me, do our steps for solving an equation. When we have parentheses, we remove those first by distributing. So this is going to be -8. And then this is going to be a -20 over 6x equals -8. Now you can reduce this fraction right here if you'd like. 20 and 6 are both divisible by 2, or we could just leave it and work with the number. We're going to get rid of the fraction anyway, so I'm just going to go ahead and leave it by that. If we reduced it, we would be multiplying by a smaller number, which might make it easier, but it really doesn't matter. So we're going to multiply each term in this expression by the number, I don't know why I did 3, because I was imagining reducing that fraction. We're going to actually multiply by 6, because that's going to make that denominator go away. Okay, so multiplying each letter. So 6 and -6 multiplied together is -36x. 6 times -8 is -48. In my fraction, the 6's are going to reduce, so that takes care of the fraction for me. And -6 and -8, -8 and 6 is -48. Next step in simplifying an equation is to simplify each term. So I got like terms, I need to add those together. So -36 and -20 is -56x, and then I still have -48. I then am going to isolate that term with a variable by adding the opposite of everything else over here. So we're going to add 48 to both sides. So -56x is equal to -48, and 48 is 0. Dividing by -56. So that reduces to x, and that equals 0. So 0 is my x value. Now that I know what x is, and I know what it's interchangeable with, I can go back to any of these original equations or this one that I solved for, substitute in the value of x, and get my y. So I'm going to go again, go back to this because y has already been solved for. So this is -2 minus, and then we have 6 times x, which is 0. So this becomes 0, so y is -2 minus 0 or plus 0, so my y value is a -2. So I have the solution to my system. In my next system, again, I look and I notice that we do not have a variable solved for, so we're going to have to do that for ourselves. I look for a coefficient of 1 among the variables. I don't have one, so now I'm looking for maybe not having to work with fractions. 8 does not divide evenly into 4. That's going to give me a fraction. 4 does divide evenly into 8 and also into 20, so I'm going to solve for this letter y. In order to do that, I need to get that y term by itself, so I'm going to add the opposite of this 8, negative 8x, excuse me, to each side. That's going to give me 4y is equal to then negative 20 plus 8x. I then am going to divide by this 4 in order to end up with just a letter over here. So the 4 is reduced, leaving me the letter y. 20 divided by 4 is 5, and 8 divided by 4 is 2. So I now have an expression that is equivalent to the letter y. So in the other equation, wherever I see the y, I can substitute in this expression. So taking my second equation then, we have 3x minus 5. There's that letter y, so we're going to exchange that y for this expression that has equal value, and then finish writing my equation. To solve an equation with parentheses, we need to take care of that first by distributing. So that's going to be a positive 25. Negative 10x is equal to negative 10. The next step is to find like terms, if there are any, on the one side and simplify. So that's going to be negative 7x plus 25 is equal to negative 10. Now I want to isolate that term that I'm solving for by adding the opposite of everything else, or anything else that's on that side. So negative 7x, this is equal to 0, negative 35. And then we're going to divide by that negative 7 to get that x completely by itself. So x is equal to a negative divided by a negative is a positive. So I have the value of x. So x and the number 5 are interchangeable in any of these equations that I started with, or this one that I solved for. I'm going to go for this one because I'm solving for y. So this is going to be negative 5 plus 2 times my x value, which I now know is 5. So y is negative 5 plus 10. So my y value is going to be a 5 as well. So I have the ordered pair, which is the solution to my system. In our final example, we have a system that, again, a letter has not been solved for us. I'm going to have to do that by myself. So we first look for a coefficient of 1, and I have two options here. This x has a coefficient of 1, and this y has a coefficient of 1. So I can solve for either of those. I won't have to divide at all, so I don't have to worry about fractions at all. So I'm going to go ahead, just because this first one's on top, and I'm going to solve for the letter x. Now, the x has to be positive, so I'm going to move the x first to the other side just to make it positive. I could move the 5y, but then I'd have to get rid of the negative sign a different way. So by adding this, that gives me 5y is equal to then negative 8 plus x. I then am solving for x, so I simply need to add the opposite of that negative 8 to get that x by itself, so I'm going to add that. So that's going to give me 5y plus the 8 is equal to x. So because I had a coefficient of 1 there, I don't have to do any dividing at all, and I don't have to worry about fractions at all. So x and then this expression over here on the other side of the equal sign are interchangeable. They're of equal value. So in the other equation, wherever I see the letter x, I can substitute in this expression here. So taking my second equation and rewriting it, 5, there's the letter x, so I'm going to substitute this expression that has equal value in for x, and then finish copying the equation, and now simply use my steps for solving an equation to determine the value. So remove the parentheses by distributing, so it's 25y plus 40 minus y is equal to 16. Simplify each term or each side of the equation by looking for like terms. So I have like terms here, so that's going to be 24y plus 40 is equal to 16. Then we want to isolate the term we're solving for by adding the opposite. So that's going to give me 24y is equal to negative 24. And then divide by this coefficient finally. And that reduces to 1, so a positive divided by a negative is a negative. Now that I know what number is interchangeable with the letter y, I can go back to any of the two original or this equation, substitute in the value of y, and figure out the value of x. So we're going to go back to this equation because it's already solved for x. So once I simplify this side, I'm going to have the number that I need. So this is going to be negative 5 plus 8 is equal to x. So x is equal to a positive 3. So the ordered pair 3, negative 1 is the solution to my system. So when you have these systems and you want to use substitution, you need the letter by itself. So if it's not by itself, you just need to move the equations around and solve one for a variable. Look for a coefficient of 1 first. Then look for a coefficient that divides evenly into all the other terms. That'll help you avoid fractions. If you don't have that option, then just pick a letter, solve for it, work with the fractions, and find your solution.